Okay, so now we look at a protocol called IGMP, or Internet Group Management Protocol, that is used to manage multicast data forwarding on our network. Actually, how to receive multicast packets on our network. So let's go ahead and do it. So multicast communication. In multicast communication, a source sends multicast data to a specific multicast address. So to forward multicast data packets to receivers, the multicast router connected to the network segment of a receiver hosts must know which receiver hosts are present on the network segment. So the router, you remember, router to receiver, the router that is connecting to the receiver must know which receiver hosts are present on the network segment, and also ensure that hosts have joined the specific group in order to receive packets for that group. So the Internet Group Management Protocol is a protocol in the TCP/IP protocol suite and is used to create and maintain group membership. That's the main purpose. Group membership between the receiver host and the immediate router, that connects this receiver. So to create and maintain group memberships. So that is what we're going to do. Winnie, please help us with reading the objectives.
On completion of on this section, you will be able to master IGMP working mechanisms and configurations, understand the differences between different IGMP versions, understand the mechanism of IGMP snooping.
Okay, very well. So let's begin with the requirements of multicast receivers so that we can understand what happens. Okay, so we already looked at the architecture. We looked at the architecture of multicast. So at the very last layer, we had the router to the receiver. So the router that is connected to the receivers. The router that is connected to the receivers. Now, this router has two main tasks. The first task is to know which groups have receivers in my network. The second task is to add members to groups on request. So members will be requesting, hey, please add me to group 1. And by saying add me to group 1, it means from now henceforth until I say otherwise, send me packets. Send me these multicast packets. So let's look here. What information needs to be exchanged between the receiver and the upstream router? So number 1, the receiver must specify the group that they want to join. Number 2, the router needs to know which groups have receivers. Why does the router need to know which groups have receivers? So that it doesn't send multicast packets if there is no receiver in that network segment. Now, this can be specified manually on the router, that in this network segment, we have members that are in group 1 and in group 2, and you can also specify that client A manually in the router is in group 1 and client C is in group 2. But if we configure that manually, then these problems occur. So manual configuration incapable of real-time updates, low flexibility. So what if now this guy wants to join group 2, means we have to manually configure again. And then huge workload, and of course, high probability of errors. So due to these reasons, that is why a protocol called IGMP was created, Internet Group Management Protocol. Now, this protocol has evolved over the years in different versions. So version 1, version 2, version 3. So we are going to be looking at how each one of them works, but majorly all of them are simply building up on IGMP version 1. So it's even more important to understand how IGMP version 1 works. So let's look at how IGMP version 1 works. Okay, so again, a reiteration, IGMP protocol, it runs between the host and the multicast router. Specifically, the multicast router that interconnects the receiver. Now, IGMP protocol provides the following functions. These are the functions that we've talked about. So the first one is for the host. It enables IGMP, use IGMP to report group membership. So to join directly to the connected routers. So it enables the host to join the group. Then the routers, they use IGMP to maintain group membership. So to know that there's someone that is in this group here, and therefore if I receive multicast packets that are destined for this multicast group, then I should send it to that guy. Okay. So let's look at the working mechanism for IGMP version 1. So IGMP, Internet Group, IGMP1 messages. Now IGMP uses two messages. One of them is called general query. General query, and number 2 is called the membership report. Membership report. So the general query, it is sent from router to the hosts on the destination address 224 multicast address, .0.0.1. .1 identifies everyone that is connected to that network segment. So this is a multicast address that almost acts like a broadcast because everyone else is going to receive this particular packet. So it is sent from the router to the host after every 60 seconds. After every 60 seconds. Now, we are going to see why it sends that particular message. Now, hosts sends a report message to join a group. To join a group. Now let's look at this scenario here. So we begin with number 1 here. So RTA. So we have a router here, RTA, that is connected to a multicast network and therefore receives multicast packets. So RTA periodically sends the general query messages to all hosts on the subnet. So general query messages, they are depicted by this red arrow. So everyone receives the general query. What is the purpose of the general query? Simply to ask. The general query is used to ask, does anyone need to join a specific group? Then number two here. So after, for example, client A receives the general query message, the host sends an IGMP report message. So the report message is still under the membership report. So it sends an IGMP report message to announce that this group still has an active receiver. So the general query asks, do we have someone in this group? Do we have someone in group 1? Do we have someone in group 2? Do we have someone in group 1? So when they receive that question, they have to respond. They have to respond. Now, let's look at number 3 here. We can see that client A and client C are both in group 1. Both of them are in group 1. So what do they say here? After client C detects the IGMP report sent from client A in the same group G1, it no longer sends IGMP report messages. Now, when the router sends a query message to ask if there is someone in group G1, now everyone in group G1 starts a timer. They start a timer. For example, let's call that timer G1. Now, this timer is a random value between 10 and between 0 and 10, and they're in seconds. So meaning that different routers in the group will randomly develop a value between 0 and 10. Then this timer will start counting down. So maybe client A has chose 5 seconds because it's a random number, while maybe this one has chosen maybe 8 seconds. So whoever's timer will expire first is the one that is going to respond to the general query. So in this case, client A is the one that has responded to the general query saying, hey, there is someone in group 1. Now, when it sends the general query, the other clients on the group are going to detect it, and they are not going to also respond and say that, hey, there's someone. No. Now, that is what we call report suppression. That is what we call report suppression. So only one client in the group is going to respond to the general query message. Okay. So I hope we've understood those two messages, general query and also the membership report messages. Like here, we've looked at the IGMP report message. So in IGMP version 1, how does a host join a group? Okay, so a host will always request to join a group. Now, for example, client D has just been connected to this network segment. So even before it receives a query, it can immediately send an IGMP report to announce that it wants to join group 3. So generally, that is how IGMP handles the joining into a group. Remember, if for example, this guy is receiving multicast packets for group 3, if there is no member, it does not send multicast packets to this network segment. But after, for example, client D sends the join message, it's going to add it, and it's now going to send packets that are meant for group D. So that's how the join is done. Now, IGMP version 1 has several weaknesses. One of them is that IGMP does not have a leave mechanism. It does not have a leave mechanism. So hosts can leave the group without notifying the router. So they can leave without notifying the router. So generally, how does the router know? How does the router know that I no longer need to send this multicast packet in this network segment? So let's look at this example. So a member host leaves the group without sending a leave message. So what will the router do? Now, if the router does not receive any response to its general query by default, so every time the router sends a general query, it sets what we call a timeout interval of 130 seconds. So it considers that the group has no members. So if 130 seconds elapse without receiving any response from that group, then it considers closing down the group. So that is the other purpose of the general query message. So the router will periodically send general query messages, and after 130 seconds, if no one responds from a particular group, it simply stops transmitting that multicast packet to the network segment, because it implies that no one is in that group. The second problem with IGMP version 1 is the Querier election, a Querier election. So who is a Querier? A Querier, for example, in this example here, we have two routers. This network segment is connected to two routers, and the two routers, both of them, are receiving multicast packets. So really, it will be unwise for the two routers to share the same multicast packets on this network segment. So we have to select one. We have to select one to be able to do that. So IGMP does not have a mechanism to determine which one is going to be selected to be the querier. So the one that will be selected to send the multicast packet is known as the querier. Then the other one, the rest of the routers are known as non-querier. So with IGMP version 1, the Querier election depends on the routing protocols. So for example, the protocol for electing a DR or something for OSPF. So it does not have its own. Now these two problems were catered for in IGMP version 2. In IGMP version 2. So in IGMP version 2, first of all, IGMP version 2 introduced the leave messages. Let me drag this here. So IGMP version 2 now, improvement to IGMP version 1. So it introduced a leave mechanism. So let's look at this. So client B wants to leave group 2. So here, step number 1. So G2's member, client B, when it wants to leave, it sends a leave message to 224.0.0.2 or 0.0.0.2. Now RTA, which is the querier, Now non-queriers do not forward multicast packets, and they also do not respond to leave messages. So RTA, the querier, sends a group specific query message. So IGMP version 2, IGMP version 2 messages. So it has introduced a leave message, and it also has another one called group specific query message. Group specific query message. Now, after RTA has received a request from client B to leave group 2, it sends a group specific query message asking, hey, is there anyone else in group 2? So that is the purpose of the group specific query message. Is there anyone else in group 2? Now, when it sends that particular group specific message, if it does not receive any report after sending two group specific query messages, it considers that G2 has no members and therefore stops transmitting multicast packets to that network segment. So after two group specific query messages have been sent, then it does not send it anymore. Now, in general, group specific query messages are sent, they're sent twice at an interval of 1 second. So 1, 2. If no one has responded, I simply stop transmitting any more multicast packets for group 2. So generally, that is how IGMP version 2 improves the leave mechanism, by using these two messages, the leave message and the group specific query message. Okay. So now we look at the query election. So IGMP version 2 defines a criteria for electing a querier. Election, so querier election criteria or procedure. Now, generally, the querier will normally look at will compare the source IP address of the message of the query message. Of course, this is the query message, because both routers will send query message. So we'll compare the source IP address of the query message to their own. So after comparing, the router with the smallest IP address become the querier. Becomes the querier. So that is how the election is actually done. Compare source IP address of the query message, because every router will send a query message. Send a query message. So in the query message, they'll carry the source address. So the router that has the smallest IP address, in this case RTA, becomes the querier. So generally, that is how elections are done in IGMP version 2. Okay. Now, I need to mention something else. So what if the query goes down? What happens? Does it mean that this network segment can no longer receive multicast packets? No. So the non-Querier routers will always send, will continue sending query messages to find out if the querier is still alive. So if they do not receive any query message from the querier before the timer expires, anytime they send a query message, they set a timer. So if the timer expires, then they know that the querier has gone down, and therefore election begins again. And again, the one with the smallest IP address becomes the new querier. So that one is also important to remember. Okay, so let's now compare IGMP version 1 and version 2. We have a number of IGMP version 1 has a number of fields. So the first one is the version, which will have the value 1. The second one is the type. The type field specifies the type of message. So is it a general query or is it a membership report message? So it will have a different value depending on that particular message. This one is reserved and is not being used at the moment. Checksum for integrity as usual. Then the group address. Now, we've said that we have two messages, general query that comes from the router to the receivers. Then we have membership report. This one comes from the receivers to the querier, and the querier is the router. So the group address, for example, the group address for the general query, the group address for the general query will always be a 0, because you're not asking a specific router, but you're asking everyone. You're not asking a specific receiver, but you're asking everyone. Is there anyone that belongs to a group? Then they're going to report. Then for the membership report, the group address is the address of the group that the sender wants to join. So a multicast address. So that is it for IGMP version 1. So we have the general query. The group address field is going to have a value of 0 for the general query. Membership report, you say I want to join group 2 by specifying the multicast address for group 2. Okay. Now let's move on to IGMP version 2. So we do not have a version field in IGMP version 2, but we have the type field, which will specify the type of message. Remember here, with IGMP version 2, it introduced 2 other messages other than general query and membership. It also introduced group specific query message, and number 4, the leave message. So this field will contain a value that relates to one of these 4 messages. Now the next field here is the maximum response time. The maximum response time specifies the maximum time the router will wait for the response to a query message. the maximum time the router will wait for the response to a query message. Then here, checksum again, then here group address. Group address. So again, I want you to read and find out what will be the group address for a group specific query. I'm sure you've already guessed. What will be the group address for a leave message? And of course, these ones remain the same. The group address remain the same as in IGMP version 1. Okay. So let's now look at IGMP version 3. Now remember, we said when we talked of multicast, we talked of 2 models. Multicast models. We talked of any source multicast. We said that this is commonly referred to SSM, and we also talked of source specific multicast, and this is known as SSM. Now, the earlier versions of IGMP can only support any source. So you cannot specify that I want a multicast from a specific source. Any source specific, any source multicast. But now, with IGMP version 3, it is going to support source specific multicast. So that when you're joining a group, you want to specify the source, because on the network, maybe DSTV is having multiple servers, sending to you the same thing. But now you want to choose that you want to receive from this server and not from this server. So that is what we call SSM, source specific multicast. And this is a capability that IGMP version 3 supports. So let's see how it does that. Now IGMP v3 messages. IGMP version 3 specifies 2 types of messages, the query and the report message. Unlike IGMP version 2, it does not have a leave message. If members want to leave a group, they simply send a report message. So it's important to note that IGMPv3 does not have a leave message. Now, the other types of messages that IGMP version 3 has is the group specific query, and it introduces a new one known as a group and source specific query. Group and source specific query. So a querier will send a group and source specific query message to members of a specific group on the shared network segment in order to check whether the group wants data from specific sources. So group and source specific query, it will send by the router to all these guys to find out whether they want to receive multicast data from a specific source. So that is what we call the group and source specific query. So router periodically sends general query messages. General query messages is this number 1 here to that, so that people can request to join the group. So the receiver host sends a report message to specify the multicast sources from which it does or does not want to receive data. So it specifies the multicast source. Now, IGMP version 3 has what we call two filter modes. So the first one is include, and the second one is called exclude. So for example, e.g. So for example, client A wants to join group 1. So if it wants to join group 1, when it sends the report, it will use the include filter. So how does it look like? It looks like this G1, then include, then it can specify the source. So maybe I want to receive from S1 and S2. When sending the report, it can also say that, hey, yes, I want to join group 1, but I don't want, exclude, I don't want to receive from source 2. Here we're using source 2 and source 1, but really it is the the address of the source, the unicast address of the source from which you don't want to receive to, or from which you want to receive to. G1 here is a multicast address of the multicast group that you want to get. So that is how then IGMP version 3 enables what we call source specific multicast. Now the other thing is this, the report message can also carry more than one group. For example, you can actually join group, you can request to join group 1 and group 2 at the same time in the report message. So this is the other feature that is new to IGMP version 3, and it greatly reduces the number of messages that is transmitted on the network. So it can request to join in the same report message. It can request to join more than one group. Okay, so let's remember the 4 types of messages that are supported in IGMP version 3, and also the filters, the include and the exclude filter. Okay, so now differences between the versions. Let me give you a minute to go through that. They're just the things that we've said. Anyone with a question so far? Anyone with a question? Okay, so are we done?
No.
Okay, let me give you one more minute. Okay, I suppose you're done by now.
Yeah.
Okay, so let's look at what we call IGMP snooping. IGMP snooping. Okay, now, as we understand in our networks, most of the time, we have the switch that interconnects the layer 2 device, which is the switch that interconnects the end devices, the hosts. So how does the switch handle multicast data? After the router sends a multicast packet to the switch, what happens? Now, we know that the switch forwards unicast packets by looking at its what we call MAC address table, the MAC address table, to check that, hey, the destination MAC address of this unicast packet is this, and this guy is connected via this particular interface. So for example, the MAC address of client A is AA, and it has been connected via G001. So it will send that packet specifically to client A. So what about multicast packets? For broadcast packets, it receives, sends out to everyone else. So what about multicast? Now with multicast, when the switch receives the multicast packet, the packet will have a multicast MAC address. So the switch will go on to check in its MAC address table, hey, do I have this MAC address? Obviously, it's going to miss it. It's not going to find it. Now, after the switch finds that it does not have that MAC address, it is simply going to send out that packet via all the other connected interfaces, other than the interface that received that multicast packet. So you see, it's like the switch now is actually forwarding the multicast packet like a broadcast packet. These indeed will lead to a waste of network resources in terms of bandwidth and also security risk, because people that are not in that group, for example, client A and client C that are not in group 2 are going to receive that multicast packet. So the solution to this is what we call IGMP snooping. Excuse me. IGMP snooping. So generally, after IGMP, snooping is enabled on a switch. The switch forwards. It forwards report messages only to its router port. Only to its router port. Now, generally, how the switch works now, when you enable IGMP snooping, is that it creates a layer 2 multicast forwarding table. It creates a layer 2 multicast forwarding table, which works as the other MAC address table that we looked at when we were learning about the switch. So generally, when it receives, for example, it receives a general query. When it receives a general query, as you can see with the red arrow, the general query is actually sent out to all the other connected devices, including the CPU of the switch, which is connected via interface 0. Now, the other thing that the switch will do is that it will actually register the destination MAC address of that particular query and the interfaces that should receive that particular multicast packet next time, something like that. So similarly, it will learn also about the report and also about the multicast packet and update the entry. So the destination MAC address of our multicast packet and members that are in that group. So for example, in this example here, we have a multicast packet that is being denoted by this green arrow. So only client B and client C have joined that group, and therefore they're going to be, so we will have in this MAC address table, we'll have the destination MAC address for that particular, the MAC address for that particular group, and for the members we'll have 3, 4. So for query messages, everyone is going to receive it. So every interface will be put here. For report and multicast messages, only specific members. So again, the table is going to be updated as these reports are being sent. Okay. So how do we configure IGMP? It's quite easy to configure IGMP in our router. Remember, IGMP is only configured on the router that is interconnecting to the hosts. So the first thing you do is you enable IGMP on system view. Then you go to that interface that is interconnecting that network segment to the hosts. So G001. So you have to configure it with an IP address. Then you also have to enable IGMP on that interface, and you select a specific version of IGMP. So for example, IGMP version 2, like that. So once you've done that, you can always do display IGMP interface, and you'll be able to see the interface and the version, for example, the state, and so on and so forth. And you can also see whether that router is a Querier. So because this is the only one, because this is the only router, so it automatically becomes the Querier. So it will have this router and the IP address of the interface that participated in the election. Okay, then you can also do display IGMP group. So once you do that, you're going to see anyone, any group, any multicast packets. So we can see that we are receiving a multicast packet with that multicast address, and we have a member that has joined that group .11. So one of the hosts there. Okay, so I think that is it. That is it about IGMP. Any questions before we try to answer these questions? Okay, first question, a volunteer.
Let me do it.
Okay.
In IGMP version 1, when the last member leaves a group, how long will the multicast router wait before deleting the multicast forward entry of the group? 130 seconds.
Yeah, true, 130 seconds. So after the router sends a query, it starts a timer. So after 130 seconds, if no one responds, it simply stops forwarding multicast packets to that particular group. Thank you, Winnie. Next. Okay, Donald, I think unakatika.
224. Okay, network yangu si poa, maybe mtu mwingine atusomee basi.
Now we can hear you clearly, eh?
Is 224.0.0.1 the destination IP address of IGMP version 2 group specific query messages? I think that is yes.
I think it's yes.
Yeah, but not sure.
So we had the query.
It's no.
Yes, Marvin, go ahead.
It's no. That one is the one for the IP address is of group to be queried.
For the query message, eh?
Yes.
Yeah, for the query message. So we're talking about the destination IP address of a group specific query message. So I didn't talk about this, but maybe we can reason together. What do you think the destination address should be of a group specific query message? Now the group specific query message, remember, it comes from the host requesting to join a specific group. So what will be the destination address?
That specific group.
Yeah, I think the destination address should be the address for that group, which is actually a multicast IP address. So please remember that. So there are such questions to confuse you, because 224 is for the query, for the very first query message that the router sends to the host. Okay, so the last question, how does IGMP snooping work? Anyone who can give us a summary? So in summary, IGMP snooping, if enabled on a switch, the switch will create a layer 2 multicast forwarding table, and thereby it will be able to forward multicast packets to specific hosts. So that's the summary for that. Please read more about IGMP snooping to understand how really the switch updates that particular layer 2 multicast forwarding table. So that's a reading assignment, don't forget. Okay, so thank you very much.